We're continuing homework 1 and we continue from the question number 9. So determine whether the data described below are categorical or quantitative and explain why. So before we turn to the question to solve, let's understand what is categorical, what is quantitative. Instead of categorical, we can call also qualitative data. So what is the difference and what is what? So we can say that quantitative data are represented by variable where the data represent amount that you can count, meaning it can be weight, it can be height, it can be age, it can be anything that you can count. It can consider quantitative. Categorical, on the other side, expressed by qualitative data and qualitative type of variables. What does that mean? That means you cannot count. That's gonna be, let's say, sex, race, that can be name of the brand, that can be, I don't know, any type of label, that can be name of the label. Okay, so let me bring example. So for quantitative data, well, let's say we are comparing the height of sport groups, teams here and there. So it's going to be quantitative data because the height we can compare, we can count, but how many feet, right? And how many inch it is in there. So how about categorical, for example? How do you know if data are categorical? If information carrying non-numerical, that is going to be categorical. Already I said it can be color, it can be brand, it can be, I don't know, language, it can be social security is categorical, although consists of numbers, but there is only one social security per person. Okay? So at this point, let's go back and solve our questions. The times of birth, babies born at a certain hospital. Now, the word itself, times of birth, meaning once or twice or 100 times, that's countable, right? So if it's countable, that means it's going to be quantitative. At this point, I eliminate the answers that carries a categorical description, which means in my case, it's falling out B and C case, and I have to choose between A and B. Okay, let's see. A, the data are quantitative because they don't measure or count anything. That is not true because do not measure, we can measure the height, you can measure the weight, and or count. So it's absolutely not true. I wanted to say a lie, but no, it's not true case. So the only case left here, D, let's read what it says. The data are quantitative because they consist of counts or measurement, period. D. Excellent. Moving to question number 10. Discrete or continuous. Okay, let me explain what is discrete, what is continuous. So, discrete data are represented by, it's a numerical type of data that includes whole number, concrete number, with specific or fixed data values. Okay, continuous data, it includes complex numbers and varying data values measured in particular time interval. To make it crystal clear, so discrete number are finite values, so you can count it, right? While continuous are an infinite number of possible values. For example, if I take the water, it's gonna be continuous, right? You can't say one water to water. Different story. One bottle, but that's bottle is gonna be keyword. So the water is flowing or doesn't have any limitation, right? It's a infinite the number. Also time also can be infinite, so it's continuous. So how about if we take the temperature? You can't count every value while measuring temperature, right? So numbers will be infinite. So at this point, it's also categorical. But if I count continuous, I'm sorry. But if I count, let's say, number of houses in the neighborhood, number of items are left on the shelf, or anything that can count it, it's a discrete. Okay, so that's different. So let's read and do this problem. So what do we have? The temperature in degrees of Fahrenheit of pizzas fresh from the oven. So since it's talking about temperature, evidently it's not going to be discrete, because I explained that temperature is continuous, right? Because you can't measure every second, every possibility of temperature. So at this point, if it's, for me, it's continuous. Therefore, two choices, discrete, B and C, falling out of game. So I will have A and D. Let's rate which one is gonna be. So A, the data are continuous because the data can take on any value in an interval. Bingo. Remember I told you that continuous can be measured in values on interval, during some interval. But out of curiosity, let's read the D. The data are continuous because the data can only take on specific values. No, that's not true. Any value it can take. All right. It's question number 10. Moving to question number 11. Okay, from sample of blah 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 adults in United States, a data set list measures and reported weights, okay? And the average mean is 178.49. Identify whether given value is statistic or parameter. I believe I explained, but I will, if I didn't explain, let me go over what is parameter, what is statistic. Parameter is a number that describes entire population. Entire population, just to remind you, we don't mean population meaning the only people. Population, it's an area, subject of our interest for statistical research. It can be, like I said, birds, all birds, let's say in United States, sharks, all sharks it can on the planet could be. What else? It could be children in kindergarten and so on, right? That's gonna be parameter. But what is statistic? Now, to make a research on any type of population, we are drawing subset, because we can't include every single element from the population. It's not possible. Therefore, we just draw some subset from here and there, and we do statistical research and apply whatever result we got, apply to population. And this is why statistics never guarantee anything 100%, because we do result based on some subset. So in statistic, usually characterize the sample, that subset we call sample. Okay, so at this point, what do we have? Let's read it then. From sample, the word already sample is there. I don't even need to read further. So it's going to be a sample is characterized by statistic, right? Population is characterized by parameter. So the given value is statistics because the numerical measurement describes the characteristics of sample, correct? Because we have sample there from the beginning. Number 12. Okay, statistic or parameter. So this one you can do it by yourself because I already explained it could be either parameter or can be statistics. Why don't you try and solve it? So question number 13. This is also about parameter and statistics. Now here is one thing you have to be when you're identifying parameter or statistics. You have to be very careful to identify parameter. Let's say if it says, for example, 3,000 people in United States where questions the age of the age, their age, so we can draw result how many, what's the average age of people in United States. Just the fact that they drew 3,000 people, that 3,000 is gonna be sample, right? It's a subset. But what is gonna be population in this case? Population is gonna be entire, all people in that live in United States. Okay? So you have to be careful so you can understand based on how you figure out its sample or population, you can figure out its statistics or parameter. So you can do this, statistic of or parameter, you can think and figure it out. Number 14, let me see what is in there. Determine whether data are from discrete or continuous. I also explained, so discrete are values that can be, data can be expressed by numerical values. Continuous, you can't express by numerical values. Continuous, it just flow. So if I take, let's say, graph, any graph of quadratic equation, linear equation is a direct line, right? It's continuous. If I take, let's say, parabola, it's also continuous. But if my graph consists of dots, then it's going to be discrete because specific value of these dots. All right? Question number 15. What do we have here? Well, also discrete or continuous. Okay. Let me do this one, just for the heck of it. If any of you is having trouble, this will help you. Okay, so numbers of televisions in different households. The fact that itself, number of the televisions in different households. Okay. I would say that the number of television that is going to be discrete because the data are discrete because the data can only take on specific value. Let me see, this one discrete and the other discrete is B. The data are discrete because the data can take on any value. No, that's a continuous. So on specific value. Fantastic. When it says any value, that means it's continuous. Okay? Moving to question number 16. Okay, what is it? Discrete or continuous? I'm leaving again on you. You can do it because I already explained. You could figure it out. So This is also discrete or continuous. Moving to question number 18. All right, discrete continuous. I'm leaving on you. You already know what it is. This is also discrete continuous. And I believe from question number 20 starts, okay, nominal ratio, that's a sampling, this is measurement, yeah. This is levels of measurement. So let me stop here up to question 19. So for measurement level, which is going to be 19, okay. And the next topic, measurement, I'll move in part 3. All right? Okie dokie. See you in next video.